Okay, so here's a few examples of t distributions. So some problems with that. And so we're still, our steps are still the same. We're still going to write down our null and our alternative hypothesis for each of these. That's the first thing we're going to do. Okay, so let's look at this. We've got a manufacturer who wants to test new engines, determining whether it meets air pollution standards. The average emissions of all engines of this type must be no more than 30 parts per million of carbon. 10 engines are manufactured for testing purposes, and the average is found to be 24.1 with a standard deviation of 3. Assuming that these engines are like a simple random sample from a very large population, and that the emissions follow a normal curve, is there evidence that this type of engine fails to meet the pollution standards? So these two numbers are big, and then this is our other big number. So this is our parameter, and these are our statistics here. Okay. So we're comparing it to there. So first thing we want to do is write our hypothesis. So we'll go with our null hypothesis first. Since this is dealing with averages, it's not much different. We're just going to compare it to the average. So we'd say that the average ppm is equal to 20. Okay, and I'm just looking at this number right here. Okay, and then my alternative is nice because it's kind of in the question here. Oops. Is there evidence that it meets or fails it? So we're just going to look at this, and because our statistic here is 24.1 and it's bigger than that, so we're just going to say that the average ppm is greater than 20. Okay, so we need to find our test statistics. So we're looking for our t-score in this case. Same thing as our z. We're looking for our t-score, which is still our observed minus our expected value all over our standard error. Our standard error is going to change a little bit though. So just quickly here, we'd say our observed, if you go back here, our observed is this 24.1. So this is going to be 24.1. We know that our expected value, we expect it to be 20. That was what it needs to meet. And then we've got to find our standard error. Okay. In order to find the standard error, we've got to be able to have our standard deviation. And because this is small, we have to have our standard deviation plus. So a little bit more here. So if you remember that formula, that was just the number of draws over the number of draws minus 1. And then we're going to times that by the standard deviation. And so in this case, our sample size was 10 here. And so our number of draws is 10. So this will be the square root of 10 over 10 minus 1, which is 9. And then we're going to times that by our standard deviation. Standard deviation was 3. And so this will be times by 3. And when you do that, you get 3.16. So we're going to use that number to find our standard error. Okay. So remember, standard error is still just standard deviation, but it's with the plus now, all over the square root of our sample space, or samples. Okay. Or sample size, sorry. So we'll go 3.16 divided by the square root of 10, because we sampled 10 in that case. And I think this gives you like 0.999, so we'll go with 1 in that case. And so now we can find our t-score. This is just going to be our observed, 24.1 minus our expected, which is 20, all divided by 1. And when we do that, we get 4.1. Oops, not 4.4. 4.1 here. Okay. So that's the little bit of a change there. Okay, and then what we want to be able to do is we want to still be able to answer our question here. Okay, so 4.1 is our t-score. That's equivalent to our z-score. Remember, that's pretty high value. So we want to be able to do our p-value, but in order to do that, we need to know the number of degrees of freedom. Degrees of freedom is the number of draws minus 1. So this is going to be 10 minus 1, which is going to be equal to 9 in this case. That's my degrees of freedom. And I need that to be able to do my p-value. Okay, my p-value, this is, remember, step 3. My p-value, remember, we're here at 0. And we had 4.1. And we want to know what's the chance that it's more than. Wasn't that what our hypothesis was? It was greater than 20. So we're looking at this way. So there's my lower bound. My upper bound is my favorite big number. And there's my standard deviation. So I'm going to go T, C, D, F. And my lower bound, again, is 4.1. My upper bound is a very big number. And then my degrees of freedom, which is 9. You use my calculator. I would do this along, like I showed you on the calculator just a minute ago. And let me just do this really quick. I don't have this one on my paper. So, and then we got times this by 100 as well. I apologize. So when you do that, you get 0.13%, which is obviously lower. Again, our conclusion is still based on that 5%. It's very, very small. It's kind of what we expect with our t-just score of 4.1. And so we would say that we reject. We're going to reject the no. Okay. So that's how you do t-distributions. We'll do another one here, but that's how you do that. Okay. So let's look at this next one. This deals with vitamin C. I like this example because of just it's very practical as far as what would end up happening here. So we've got a vitamin pill as advertised of containing 500 milligrams of vitamin C. A consumer protection organization wants to make sure that's true. Average isn't much different than that. And so they sample 7 pills to assess this. You guys can see the following amounts that they found in those 7. And so we want to know, is there a problem with the amount of vitamin C in this? So this is, the reason why this are very nice is because it costs a lot of money to make these vitamin C pills, and you don't want to be destroying every pill. And so that's why you have to do a t-distribution, because you're going to have a small sample. You don't want to do... You don't want to just destroy your product over and over again. So that's why this one is nice that way. Okay, and so remember what we need a few different things. We've got, this is our expected value right here. That's nice. We need our observed average. So to do our observed value, we've got to do our list. Okay, so let's go do that really quick. So we're just going to use our calculator for this. If you guys remember how to do this, we're going to put in a list here. Whoops, sorry. No, we're not going to do that. We're going to go math. Nope, no, stat. Sorry, my bad. I hit the right key, just had the wrong thing. We're going to edit here. We're going to put our list in here. Remember, if you have this list, you'll want to delete these or clear them. Okay, so we're just going to enter in our list how we had here. And so this first one, we're just going to go 498. And then we're going to go 513. You guys remember doing this? Hopefully it's been a little while since we did this. I just want to do this one because this one involves your calculator a little bit more, I guess, because of this part I don't actually give it to you. 515 and 504. Okay, and then we're just going to hit second var. Whoop, nope, sorry, take that back. Apologize. We're just getting var. No, stat. Come on now. Done this, it's been a little while. And we're going to go over to calculate. And we want the one var stat. And we want that list. So we'll go down here to calculate. And if you guys remember, my mean is this very, very top one here. So the 5.7. The nice thing about this, if you guys remember when we were first talking about the SD plus, I told you it was that S with the X. Well, look here, your calculator does that to SD plus. You can use the formula if you want, but your calculator does it for you. So this 11.79 is that to SD plus. Okay, so that's what we want to do for that. Okay, and so let me just jot those down again. This was our EV, our expected value. Our observed value was, remember, 507.43, I believe. And then remember, I looked at that SD plus, or remember it's that S with the X. That was 11 was 11.7, 11.79, I believe. So just keep that in mind. We've done that. So, all right. So hypothesis test, so our null is just going to be that the average equals 500. Okay. And then my alternative is that the average, because we have 507, that's bigger, the average is more than 500. Need to find my test statistics, so I'll find my t-score. Remember, that's my observed. My observed was that 507 that I just found in the calculator, minus my expected, which was 500. Then I'm going to divide that by my standard error. So to find my standard error, remember, I need to know my SD plus. Again, if you want to use your formula, you can. Remember, it's the number of draws, 7 over 6. And then we're going to times that by the standard deviation, which I didn't write that standard deviation down from the calculator, but it was, I think it was 10.9. And you'd have to get that from your calculator. Or remember, this is just the same thing as that S of X, which I wrote on that previous slide, which was 11.79. And then my standard error is just going to be 11.79 divided by the square root of my sample space, which was 7. And that's going to give me 4.45. So I subtract those, divided by 4.45, and I get 1.67. Okay, then I'm going to do my degrees of freedom. Remember, that's draws minus 1. So that's going to be 7 minus 1, which is 6. Find my p-value. So we are, my z, or my t-score was 1.67. Right there. I want to know more than. So I'd go TCDF. My lower bound, which was is 1.67. My upper bound, which is 500. And then my degrees of freedom times by 100%. And when I do that, again, you guys can do this, I'm going to get 7.3%. And so this is greater than 5%. And so I'm going to conclude that I'm going to do not reject the null. Okay, that would be my conclusion. Okay, so that is t-distributions, only when we're doing small sample size. So there's 2 examples for you. You should be able to do that from the assignment as well. So.